Good afternoon, mathematicians. Thank you for your patience today while I'm not at school. I appreciate everything that you are doing to make our substitutes day a little bit better. Today you will be practicing completing the square, and our essential question for the day is how can I use algebra to complete the square for situations that wouldn't make sense as drawings? So I have pulled question 4 from your worksheet from Friday. And this one really showcases why this algebraic process is important because this middle term here, this minus 12x, would be really hard to draw as a picture that made actual sense because we'd be taking away those x rectangles from our drawing rather than being able to add them on. So we're going to follow the same process to complete the square. It's going to happen relatively easily the same. Um, I would like you to follow along with this one if you could. There is another example of a negative down in question number 8. Um, so if you want to try one on your own. As a reminder, all of the work that I am doing here, as well as work for all the rest of the problems, is available on Gradient as an answer key in the worksheet assignment. All right, let's get started. So for this first piece, all we are doing is we are looking at the middle term. And we'll take the coefficient from the middle term. That's just the minus 12x. So we're doing minus 12. We don't actually need the variable because all we're trying to do is figure out how many of the rectangles will be on the top and how many will be going down the side. In this case, there'll be negative rectangles, which should be all right. So we're going to divide that in half, so divide by 2, and come up with negative 6. Now this negative 6 piece seems pretty reasonable. What we're going to do with that is we'll take our answer here, this negative 6, and we're going to square it. Remember, when I square a negative, it's always important to remember our parentheses if we're going to put it into the calculator, because it's negative 6 times negative 6, not negative 6 times 6. So in this case, I've got a negative times a negative gives us a positive. 6 times 6 is 36. All right, so that's the number of pieces that we want, the single unit tiles. That's not the same number that we have. I have 11 unit tiles and I need 36. So in order to figure out what's going to happen, we'll take those two numbers and subtract 36 minus 11 to figure out how many more I would need to add to 11 to get to 36. 36 minus 11 is 25. So I'd need to be able to add 25 more to that 11 to make it look like a 36. If I'm going to add 25 without changing the value of this equation, I would have to subtract 25 as well. So let's go ahead and rewrite our equation. Y equals x squared minus 12x plus 11 plus 25 minus 25. Now what I'm going to do is keep the plus 11 and plus 25 as one piece that can equal 36 and leave the minus 25 on the outside. So if I rewrite this, it will look like y equals x squared minus 12x plus 36. minus 25. Notice how that's giving us the equation that we're hoping for. This right here is how we can describe our square, even though it has negative x's in it. Okay, so from here, we're going to write the square as a description, like the area of the square, as a descriptor of its two sides multiplied by themselves. So one side is going to have a length of x and a length of negative 6. This negative 6 is coming from right up here or here. That's half of the negative 12s. So x minus 6, there's two of them. So multiplied by itself again. And then minus 25 is still hanging out on the side there. We can consolidate because anything times itself is squared. So we can make it look a little bit neater that way. And hey, look, we're in vertex form. All right, guys, vertex form is really fun because you can graph by knowing the vertex and one point on either side of that vertex, either side of the line of symmetry in your parabola. The parabola curves, so right smack dab down the middle, we're trying for a point on one side and a point on the other side. Okay, so I need to find my vertex. I'll find a point on the left and a point on the right. All right, vertex form is y equals a times x minus h squared plus k. In this case, our a is equal to 1 because there's an imaginary invisible 1 right there. It doesn't show up because there's just one of them. Convention says it doesn't need to be there. H is the number that's being subtracted inside the parentheses. Well, it looks like the number being subtracted in those parentheses today is 6. And then K is the number being added on the outside. So added to the outside, it actually looks like subtraction. So added to the outside in this case is minus 25 or negative 25, however you prefer that. So for the vertex, it's just h comma k in parentheses. That's our ordered pair for graphing the vertex. It looks like this case, it is 6 comma negative 25. And now we need to find a point on either side. It does not matter which point we choose. So I'm choosing a value for x that is lower than 6, because that's the value that we came up with for the vertex. And then a value for x that is higher than 6. It shouldn't matter which one we pick. So I'll do 5 for my lower value. Maybe I'll do 10 for my higher value. The goal here is just to keep them kind of close because if you get really far away from the vertex, it's going to be hard to graph. Okay, so point 1 was 5. So I'm inputting 5 into an equation. I could put it into this equation up here. It might be easier, however, to put it into this equation down here because there's only one place that I'd have to replace x. So let's start with point 1's calculations. I've got x minus 6 quantity squared minus 25. And I'm going to erase x and put in 5 instead. 5 minus 6 is negative 1 squared minus 25. Negative 1 times negative 1 is positive 1. 1 minus 25 is equal to 24. Okay, so 24 goes here. All right. Next, we're going to try again with 0.2. 0.2's value for x was 10, so I'll replace that 5 and make it into a 10 and see what happens. 10 minus 6 is 4. 4 squared is 16. 16 minus 25 is not, oh, that was a negative 24, huh? It's not negative 24. It's going to be negative, well, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I guess it's negative 9. And so negative 9 goes right over here. And I've got 0.1, 0.2, and a vertex. All right, I'm going to copy these and bring them down to a new page so that we can graph this. It looks like I'm trying to fit the 0.6 comma negative 25, 5 comma negative 24, and 10 comma negative 9 on my graph. Here we go. X-axis, I'm putting it really high up because all of my y values are going to be negative y values. I need to make sure that there is at least 10 spaces over here on the right of my x-axis and at least negative 25 spaces on the down section of my y-axis. So let's count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, just enough. I don't need anything in the negatives over here, but I'll label them just in case. Now, I think I won't be able to get to negative 25 on my y-axis with a 1-by-1 scale. So I think I'll scale by 2s. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20, negative 22, negative 24, negative 26. Oh yes, I will make it just fine. Okay, now I'll plot my points. My vertex was at 6 comma negative 25, so 6 negative 25 sits right in here. My point 1 was at 5 negative 24. That sat right there. And my point 2 was at 10 negative 9. That one sits right here. So in order to graph this lovely parabola, all I'm going to do is make sure that I'm going through all of my points. Cool, done. All right. If you have questions, feel free to shoot me an email. I'll try and be checking those during your period today. Um, but aside from that, good luck. You can do it. I believe in you. Have a good day.